Today we're talking about 2 of the tests that are on your paper that I handed to you, out of the 9. Okay, these are 2 ways to figure out if an infinite series diverges or converges. Okay, they are the 2 most basic. We'll talk about p-series in a couple days. That's the other easier one. Okay.
With geometric sequences, will they always be exponential?
That's the point of it. Yeah, it's
exactly what it is. So geometric series is just like the geometric sequence, except that it puts it in a series, right?
So when does a geometric series diverge? Or converge?
What do you think would happen if that's true?
What was I saying?
The R is what we remember sequences. We looked at the R to determine convergence and divergence. Okay, so if R is less than 1, or the absolute value, so that, again, remember absolute value means that. Right, that's what this means. Does that series converge or diverge? Let's take a stab at it. What do you think?
Converges?
Okay. It's exactly what happens. It makes fractional ratios, right? So the series converges. Okay, and then the other that we can have is everything else.
Series is only integers, right?
Yeah. We diverge. Okay.
And I'll show you a couple examples of that. Let's make this right here any number. So I change that to any number. It could be 0, 1, 2, 3, 4. Okay. Here's the neat thing about geometric series. We can actually calculate what that series converges to. This is the formula. Okay. And that formula is that's the structure behind geometric series conversion. All you're looking at is the R. The R is between -1 and 1, converge. It's bigger than or equal to 1, diverge. Okay.
Let's look at a couple examples.
And here's one.
So they will, geometric series will come in many formats.
What you have to do is manipulate things to make them look like a geometric series.
Can you make that look like a geometric series? If the answer is yes. What is it then?
Isn't that already a geometric series? It's just missing C, which technically be 1.
So looking at geometric series, we have a ratio to the nth power, positive nth, okay? How would I make this a positive exponent?
Take it down.
Yeah, drop it in the denominator. Okay, but does that match this format yet? Is that 1 over r to the n? No, it's not. So how would I make this something to the nth power?
Multiply by 5
What's 1 to the nth power? Seriously.
It's 1.
1. Any 1 to any power is 1? So we can actually do this, right? Hey, you're not participating either.
I didn't know either, that's why I said
Okay. Oh, man. Math 1, here we come. What's our C value? Remember we have a C here?
1.
Yeah, it's 1. So there's your geometric series. Correct?
Yes.
Okay, does it converge or diverge?
Coverage.
Because
Less than 1.
what is
R
less?
is less than
Okay,
1.
converges. Because R is less than 1. Okay, what is the sum? The sum formula, correct? Okay, so what is our C? 1, R is 1/5 to the 0, and 1 minus 1/5 on the bottom.
And that's 1 over 4/5.
Yep.
So 5 over 4, yeah.
Good work. There's your sum. So that's the upper bound, right, of that geometric series. So geometric series, again, very unique in the fact that we can actually calculate that number. Okay.
Why is it just 0? Why is M 0?
And a 0. There's the formula with n equals 0 doesn't have the r to the n in it, because that's 1. But I give you this just so you can deal with any situation that pops up.
Yeah.
Okay. So instead of remembering 2, it works every time. So
Number 1 that we have used.
it's no more simple. Let's see. Let's try one a little bit more saucy.
All right then.
How do I put that in the format that I need it to be in to be a geometric series?
I'm pretty sure we did something, didn't, but the.
Times it by 2.
Can't do that, there's no equal signs.
Ow.
Well, factor,
Factor what?
I don't know, but that's, you can't subtract.
All else fails, factor.
You can't subtract, add, divide, or multiply, so you have to factor.
Yeah.
Or break it apart and do 2 plus 3 to the n times 1 over.
Can't you separate those up to do 2 over 5n and 3?
Genius,
Mason figured it out.
just walked in the building.
You're welcome.
What?
Pretty challenging.
I thought mine goes big, but I can't compare them on things.
Mason, you're the only finished with science in school.
Okay, can you make
That's sad.
those 2 different geometric series? We have 2 series here.
Yeah.
Yeah, okay. What are they?
Oh, it's gross.
Isn't 1 just 3/5 to the power of n?
What's this one become? What's our C value? 2. And just like the last question, 1/5 to the n,
Why 1?
because it's 1 over 5 to the n, which is 1/5 to the n. Same thing. Plus, if you're writing this mathematically correct, you have to separate it. It's called the linearity of series. It's just like integrals or anything else. You do it term by term. Now we have two separate series to evaluate. Do they both converge?
Yes.
Or look at your R values?
If we slow down just a bit, that'd be fantastic.
Sorry, I just get so excited.
The excited are just going to be done with the problem, because you know that it's going to take forever.
No, I get excited.
So for the 3/5, and you just took out the n, what's the exact process for that?
Well, 3 over n, 5 to the n. It's the same as 3/5 to the power of it. It's a property of exponents.
Okay.
Okay, so we converge, right? Okay. That's an R. All right, what do they converge to?
Would you have to figure that out separately?
Two different, yep. So C R to the n over 1 minus r plus
Yeah, I got 5.
Is that right?
Yeah. I got 5.
Five. Got it. Okay, there you go.
Where did the 4 come from, bottom 10?
It's 1 minus 1/5 is 4/5.
Oh, no.
Math.
5 times 2 is 10.
Gotcha.
Okay, math. Honestly, math 1's not even on that level yet.
You guys got a game today? What do you do?
Okay, so that's series test number 1 for convergence.
That's not too bad.
Right, exactly. You just have to remember it amongst the sea of other tests. Okay, here's number 2. It's called the divergence test. We talked about it yesterday. Some people call it the nth term. I think AP calls it the nth term test.
That's what your sheet says.
Nth term?
Yeah.
Okay. Your book calls it the divergence test. All right, so it says if the nth term of a sub n does not converge to 0. That's right. What's that? Does not converge. Okay, sequence or series?
So you want your sequence.
That's a sequence statement, right? So keep that in mind. This is a sequence statement. Then, series diverges.
So that's just the inverse of what we talked about yesterday.
So A sub n, just whatever the series is without the summation.
It is the
Because we were talking about how
contrapositive.
Yeah.
Because we were talking about if A sub n converges, then the sequence converges to zero. Again, remember contrapositive, converse, inverse, we talked about that the other day. The contrapositive is always true if the statement is true. So if the series converges, then the sequence converges to zero. Okay, but we can't apply any other mode of thinking around that. We can't say, if this diverges, then the sequence diverges, or if this diverges, the sequence does not converge to zero. Not a true statement. Okay, so keep those little things in mind. How do we use that? Infinite limits.
Yeah.
So, and the drawback of this is it only shows divergence. It doesn't tell you something converges. Okay. So if this doesn't tell, if this sequence does not, or converges to something other than zero, we know it, the series diverges, but if it converges to zero, we don't know anything about the series. Okay. So, let's look at something like this. So we're just going to use an infinite limit to evaluate this. So if you look at a series and you say, what's the infinite limit?
It's fourth.
A fourth, is that zero? No, series diverges.
Oh, huh, that's nice.
Right? Okay, so formally write it out. Right? By the Nth Term Test. The series diverges. Okay? So it's pretty handy. Just doesn't show convergence. But it is a nice thing to have in your hip pocket. Questions? There. Okay, let's look at a different one. It's got a little twist to it. Let's make that open.
I recognize that. Yeah.
Alternating, I heard the word.
Yeah.
Okay. So, but what do you notice about this term if we do the infinite limit? What's the limit as n approaches infinity here?
1.
1, right? So we're going to try to use a divergence test, but we have this to deal with. Okay.
Oh.
What do these terms actually do if you graphed it out? Like if you
Is this
plug
the
one
one
in-
Closer to 0, aren't they?
So here, what are the terms? 1/2 minus 2/3 plus 3/4 minus something.
Is this the one where
The
it's,
sum is doing this,
that sequence you were talking about,
right?
where like it goes from 0?
Does the limit exist?
Yes. No.
No.
Does not.
Where does it be?
Okay. This is the limit does not exist.
This doesn't work.
Okay, now look at the theorem. What does it say? Does not converge to 0. Does that meet the criteria?
Yes.
Yeah, it does. So we can say that that series diverges.
But using this test, you can't say that if the limit converges to 0, you can't be like,
You cannot.
it's so simple.
Yeah. I'll show you an example. I think I already showed you one. There are examples where the series, let me back up. There are examples where that is true. The sequence converges to 0, right? But the series
Doesn't have to.
diverges. Okay. One is these are called p-series. It's based on the exponent of the denominator. Here's another one. Those both diverge, amazingly enough. And you'll again learn how to do that with what's called a p-series. It has to do with the exponent. That's 1, right? What's the
Yeah.
exponent here? It actually is the exact opposite of the geometric series. If the exponent's less than 1 or equal to 1,
Oh, I thought you were gonna say it's R minus 1 over Cn.
no. So we'll go over that in a couple days, but those are a couple of series where the sequence goes to 0, but they diverge. That's why we can't say that. Okay. Questions? I mean, I could show you that mathematically if you'd like, why that works. You could trust me, or I can show you.
Trust.
I'll trust.
All right, that's all I have for today. You have about 10 minutes to work on this stuff. If you want to get started, I think, I wrote it all down yesterday.
Yes.
Do you want me to write it again?
Yes.
Can Lisa check her tenth not a question?
It's not.
The book?
Check the 10 from the book. It's not.
Yeah, take your book home. I don't know if I have a copy of that, but I'll look.
Hunter, do your job.
It's in my car. It's always that way.
No,
How do you say
That was
Here's
last
my-
year's
teacher
as his TA.
My TA, dude, do
Oh.
your job.
Well, I need something with a PDF scanner on it.
Download the PDF scanner in your Chromebook.
I can't download crap on my Chromebook because it's a school Chromebook.
It's about to become your Chromebook.
That's true.
Go talk to Miss Tracy. She always scans stuff for me.
I can scan stuff. Okay, so there you go. Again,
Yeah, but then